Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on simultaneous equations using the elimination method. So we used the substitution method last lesson, but that's not always easy to use. So sometimes we need a different method, and that's what I'm going to show you today. So our goal is still the same. We will have two equations with two variables, and we need to find a solution that solves both equations simultaneously. So let's look at an example where we might use the elimination method. So let's look at this example here. So we have two equations, two variables, x and y, and we want to find a solution that solves both of these at the same time. The problem with trying to use the substitution method is that neither equation is in the form x equals something or y equals something, and if we wanted to put it in that form, it'd be very hard. Let's say, I'll call this equation 1 and this is equation 2. Let's say I wanted to change equation 1 so it was in the form y equals something. So then I'd get 3y equals 17 minus 2x, and I'd have to divide by 3. Okay, as you can see, this is quite messy. Okay, it's got a fraction 17 over 3. They're not nice numbers. I won't do that at all. So I want another method. So the elimination method involves eliminating one of the variables because we know how to solve an equation if there's just one variable. So this is what you do. What you do is you add or subtract the two equations in order to get rid of one of the variables. So here, if I subtract the two equations, if I subtract equation 2 from equation 1, then I'll get rid of the x's. So let's do that. So 2x minus 2x is 0. 3y minus 5y, you've got to be careful about that, becomes positive 8y. Equal sign under equal sign, and I go 17 minus 7 equals positive 24. So by adding the two equations together, I've got a really easy equation to solve. 8y equals 24. So then I divide each side by 8. I get y equals 3. If y equals 3, I substitute that into either equation. Doesn't matter. I'm going to choose equation 1. So I've got 2x plus 3 times y equals 17. 3 times 3 is, of course, 9. You know how to solve these. We've done a million of them. Subtract 9 and divide by 2. So, of course, that will leave me with x equals 4, and my solution is x equals 4, y equals 3, and I'm done. Okay? So let's look at another example. So let's try these equations here. So again, I have two equations, two variables, and want to find a solution. Problem, it wouldn't be easy to use the substitution method. So I'm going to use elimination again. So last time I eliminated the x's, and the reason I chose to eliminate the x's, it was easy to do it because they both had the same coefficient. They both had the same number in front of. So here you can see that the y's have the same number in front of. So I'm going to eliminate them. So last time I subtracted the two equations. Well, that wouldn't work here because negative 2y minus 2y is negative 4y. It wouldn't get rid of the y's. What I actually need to do here is add the two equations together. So I've got to take the first equation and add it to the second. So 3x plus 4x is 7x. Negative 2y plus 2y is 0. That's the elimination. The y's are gone. Now 11 plus 38 is 49. So again, easy equation. 7x is 49. X is 49 divided by 7, which is 7. So now I've got to find y. I've only found x. So 3 times x minus 2 times y is 11. So 21 minus 2y is 11. So this one's a little harder to solve, but you can still do it. Subtract 21 from both sides. Now I need to divide not by 2, but by negative 2, and y is positive 5. And that's the answer, 7, 5. Okay, it solves both equations simultaneously. So how do you know when to add the two equations or subtract the two equations? Well, that's really simple. So follow the instructions in the green box. So you always want to eliminate the variable that has the same number in front of. So here we eliminated the x's because they both had a 2 in front. Here we eliminated the y's because they both had a 2 in front. So if the number in front of that variable has the same sign in both cases, you subtract. So the 2's here were both positive. That's why we subtracted. Here in the second one was a -2, one was a +2. They had a different sign, and that is why we added the equation. So make sure you follow that. So I've just got to show you a slightly harder example now, so please pause and copy this down if you need. So let's have a go at this question here. So again, probably not easy to use the substitution method because it's not in the form x equals something or y equals something, and it would be hard to get it in that form. So we want to use the elimination. The problem with the elimination is you can see that neither x nor y has the same number in front of. But we can get around that. So what we do is we can multiply either equation by a number, as long as we multiply everything in the equation by that number. So if I multiply this first equation by 3, that will change the number in front of x here to 6, and then I can use elimination. So let's go ahead and times everything in the first equation by 3. So 2x times 3, 2y times 3, 30 times 3. Now the second equation, I haven't actually done anything to it, okay? So now you can see that I have 2 equations and the number in front of x is the same in both equations. They also have the same sign, they're both positive. So I need to subtract. I need to subtract the bottom from the top. So 6x minus 6x is 0. 6y minus 3y, be careful with that, is positive 9y. 90 minus 27 is 63. So 9y, 63, y equals 7. Now I substitute into either equation to find x. So I'm going to substitute y equals 7 into this equation. So 6x plus 6 times y equals 90. So 6x plus 42 equals 90. Subtract 42 and then divide by 6. X equals 8. So the solution is 8, 7. Okay? The last example I show you is going to be really hard. So let's have a look at these 2 equations here. Again, it'd be hard to use the substitution method. I want to use the elimination method, but neither x nor y has the same number in front of. What makes this so hard is that I can't times either equation by a whole number so that it has the same coefficient as in the other equation. So in those cases, I need to times both equations. So I am going to get it so the x's have the same number in front. So if I times this by 3 and this by 2, they'll both have a 6 in front. So I'm timesing it by the coefficient of x in the other equation. So I'm going to times the first equation by 3 and the second by 2. So let's first times the first equation by 3. So minus 2x times 3 plus 5y times 3 and negative 14 times 3. Now I'll times the second equation by 2. 3x times 2 minus 7y times 2, 20 times 2. So now you can see the x's both have a 6 in front of them. They have different signs. One's a negative, one's a positive, so I need to add the 2 equations. So negative 6x plus 6x is 0. 15 plus negative 14y is just 1y, or y. Negative 42 plus 40 is negative 2. So y equals negative 2. Again, I substitute into either equation. I'm going to substitute into this first one. So negative 2x plus 5 times y equals negative 14. So I have negative 2x minus 10 is minus 14. Add 10 to both sides. Make sure you're all good with your positives and negatives here. Use a calculator if you need. Divide by negative 2. I get x is positive 2. So that's my solution. Okay? So hopefully you haven't found this too complicated. I know it's difficult. This has been the luckiest maths teacher in the world. Have a great day.